Now that we have a pretty good handle on our basic trig functions, sine, cosine, tangent, and we've looked at the reciprocals of those functions, cosecant, secant, and tangent, we're ready to move on to inverse trig functions. All right. A lot of times we get some confusion here because we hear inverse and we start thinking inverse is like reciprocal. That doesn't work in trig. Remember that sine and cosecant are reciprocals, and inverse is something a little different. An inverse trig function works like this. Let's say we wanted to find the cosine of an angle. We knew that the cosine of that angle is square root of 3 over 2. But we want to know what this actual angle measurement is. Okay, is it a 45, a 30, a 60, a 50? What is it? Well, we can use inverse trig functions to find this, and you will use your graphing calculator for a lot of it. I want to show you intuitively how it works first, because there's some of these you can do without a calculator. Let's say we wanted to find the cosine of x. We knew it equaled square root of 3 over 2. So I just drew kind of a dummy triangle here. We're trying to find x. Well, the cosine of x is going to be the adjacent side over the hypotenuse. So we know the measurement of the adjacent side. We know the measure of the hypotenuse. Okay? At this point, these numbers should start looking familiar. This is one of our special right triangles, a 30, 60, 90. So, let's just plug in. We know our final side length is 1. So, what angle is opposite the measure of 1? Well, in a 30, 60, 90, if you think back, and you do need to have this memorized, x would have to be 30 degrees. So in this case, x is 30 degrees. Okay, we can find it intuitively without the calculator. Let's try a couple more like that. The sine of our angle is 1/2, so I drew out a dummy triangle again. So we know that the sine is the opposite over the hypotenuse. So opposite our x is 1, our hypotenuse is 2. We can see again this is shaping up to be a 30, 60, 90. So we're going to have square root of 3 over here. So again, what do we have here? We're going to end up with another 30-degree angle. Okay? Because again, opposite the 1 in a 30, 60, 90 is the 30-degree angle. Okay? Again, a couple that we can find without even the use of a graphing calculator. Let's do a couple more. Let's say we want to find the tangent of an angle is 1. We want to find out what the angle actually is. Well, if you remember, 1, let's write it as a fraction first. 1 over 1. So if we think about this, tangent is opposite over adjacent. So in this triangle, the opposite side is 1, the adjacent side is 1. Again, we should look pretty familiar here to one of our special right triangles. This is a 45, 45, 90. This is going to have a length of square root of 2. So since it's a 45, 45, 90, x will obviously have to be 45 degrees. Okay? Let's do one more like that. The tangent of x is the square root of 3. So we have, right, this is a fraction, square root of 3 over 1. Tangent is opposite over adjacent. All right, so our opposite side of the x is square root of 3. Our adjacent side is 1. We should be looking familiar here again. This is a 30, 60, 90. Our hypotenuse is going to be 2. So, what angle is opposite the square root of 3 in a 30, 60, 90? That is a 60-degree angle. Check back on your notes for your special right triangles if you need to remember this, but a little bit of it's just a refresher of that. And that's a good reason to go through these intuitively. Well, the problem is we're not going to deal with everything that works perfect all the time like these two special triangles. Most triangles aren't. So we need another strategy. Well, in this case, the best strategy is just the calculator. Let me show you why it's kind of hard to do these always intuitive. Tangent of x, we want to find x is square root of 3 over 3. Tangent, again, is opposite over adjacent. So opposite our x, we put square root of 3. Adjacent, we put 3. Now, this does not look like a special right triangle. So we are good and we are best to use our calculator. So I'm going to kind of hold it up here, hopefully so you can see. There we go. All right. Well, in this case, we know the tangent of an angle is equal to this. This is where we use our inverse trig function. So if you can see it right there, our tangent button's right here. We want to use that inverse, that to the power of -1. So we hit second and tangent. Now, inside of that, we put the square root of 3 divided by 3. And you need to enter this carefully. So, second, we have to go and press our square root button. And 3. So we have that. Now, we need to arrow over here because we want to take all that and we want to divide by 3. Close our parentheses and hit enter. And it tells you what the degrees are, as long as you're set on degrees on your calculator. So, this angle x has to be 30 degrees. Okay, let's look at one more example. Again, as long as you get it entered in the calculator right, the calculator works very well. The cosine of x equals square root of 2 over 2. So, we go to our cosine and we want to use the inverse function. So we hit second and we hit cosine. Now, we want the square root of 2. I'm going to have to pull away here and look at this. Square root of 2. Arrow over, so we're not putting it all under the radical. Divided by 2. Close our parentheses and hit enter. And we'll see we got a 45-degree angle. So x equals 45. So, if we know what the ratio of these sides are, we can then go back and find the angles. If we know the angles, we can find the ratio of the sides. This all kind of works together. So, go ahead and work the example problems, and we'll see you in the next video.